Hi students, good morning. Now write down the area inscribed area of triangle inscribed in a parabola is 1 by 8a into mod of y1 minus y2 into y2 minus y3 into y3 minus y1. Area of triangle inscribed in a parabola is y1 minus y2 1 by 8a into y1 minus y2 y2 minus y3 y3 minus y1 where y1 comma y2 comma y3 are ordinates of its vertices. Ordinates of its vertices. See here, this is the parabola. So the point is P and one point is Q and one point is R. So the 3 points so forms a triangle. The point is E, x1 comma y1, where that is a t1 square comma 2a t1. One point is, and this point is x2 y2, that is a t2 square comma 2a t2, and one point is x3 y3. So this is a t3 square comma 2a t3. So 3 points, take the parametric coordinates. Now area of triangle PQR is equal to area of triangle formula 1/2 into determinant of, you know this formula, x1 y1 1 and x2 y2 1 and x3 y3 1. Area of triangle formed by 3 vertices x1 y1 x2 y2 x3 y3 is, this is the formula, that is equal to determinant of here x1 is a square 2a 1 and a 2 2a 1 and a 3 2a and it is 1. Now from the first column a is taking common, from the second column 2a is taking common. So this is 1 by 2 into first column a common and the second column 2a is taking common. Determinant of t1 square and this is t2 square t3 square. This is t1 t2 and t3 1 1 1. So there it is 2 gets cancelled. So there is what, a square into, so that is the determinant of the matrix. So this is a square. Now here you can convert R2 changes R2 minus R1, R2 changes R2 minus R1 and R3 changes R3 minus R1. So this is a square. So this is a square into a square. First row is fixed here, first row. So this is the t1 square t1 1 and the second row changes R2 minus R1. So this is a t2 square minus t1 square, t2 minus t1 and it is 1 minus 1 is 0. R3 changes R3 minus R1. This is T3 square minus T1 square, T3 minus T1, and it is 0. Now it is equal to A square into determinant of T1 square T1 1, and this is A square minus B square, A plus B into A minus B, T2 plus T1 into T2 minus T1, and it is T2 minus T1 0. Next one, this is also A square minus B square form. This is right, T3 plus T1 into T3 minus T1, T3 minus T1, and it is 0. Okay, from the second row, T2 minus T1, T2 minus T1, this is 0 into T2 minus T1. So this is taking common, T2 minus T1. And the third row, you can take T1, T3 minus T1 is taking common. Just write down. So second row T2 minus T1 common, third row T3 minus T1 common. So this is A square into T2 minus T1 into T3 minus T1. So this is the T2 T1 square, T1 square, T1 1, and it is T2 plus T1, and it is 1 0, T3 plus T1 1 and 0. So this is expanding along first row. So this is A square into everything is a determinant of the matrix. So this is T2 minus T1 into T3 minus T1 by expanding. So this T1 square into, by deleting first row and first column, first row and the first column, expanding this. So this is first row into expanding, or you can take first row and first column. So this is 0. So okay, next minus T1 into, by deleting this and this. So this is also 0. Now this is what, 1 into, so it is clearly 0. Or expanding along this C3, 1 into this. So this is 1 into T2 plus T1, these two, minus T3 minus T1. Expanding along, this is C3, third column, 1 into, so by deleting this and this, 1 into deleting first row, and this is third column. So determinant of this matrix. Therefore, this is the T2 plus T1 minus of this, that is minus T1 minus T3. So these gets cancelled. So everything is under modulus values. So that is A square into, here you can write mod of, or write T1 minus T2 into T2 minus T3 into T3 minus T1. So this is determinant of the matrix. So this is area is, now, so A square, we are multiplying and dividing by, so this is multiplying 2A. So this is T1 minus T2 into multiplying 2A for this, T2 minus T3 multiplying this 2a into t3 minus t1 by 2a, 2a, 2a. So this is 8a cube. That is equal to 1 by 8a. A square gets cancelled. 1 by 8a. Determinant of this is 2a t1 minus 2a t2. And this is 2a t2 minus 2a t3. And it is 2a t3 minus 2a t1. What about this one? This is nothing but y1. This is y2. What is x1, y1? Here, the point x1, y1 is x1 comma y1 is equal to a t1 square comma 2a t1. Therefore, this is y1 and it is y2. y1 minus y2, y2 minus y3, y3 minus y1. So, this is the required area of triangle inscribed in the parabola. Okay, write down. That is equal to 1 by 8a into, so this is y1 minus y2, y1 minus y2 into y2 minus y3 into y3 minus y1. Next one, the area of triangle formed by the tangents area of triangle formed by the tangents at the points x1 comma xi comma yi, where I is equal to 1, 2, 3. That is x1 comma y1, x2 comma y2 and x3 comma y3 to the parabola y square is equal to 4ax. Y square is equal to 4ax is 1 by 16a into y1 minus y2 into y2 minus y3 into y3 minus y1. Area of triangle found by the tangents at 3 points. See, this point is x1, y1. Okay, and this point is x2, y2. x2 comma y2, and the point is third point x3 comma y3. x3 y3. So this is tangents and also this is tangent. Now this point is A and this point is B and this point is C. Now area of triangle found by the tangents at 3 points. Previous one is inscribed in the parabola. Area of triangle found by the vertices x1 y1, x2 y2, x3 y3. Here the problem is formed by the tangents at the points. Means you have to show that the area of this triangle formed by the tangents area is this one. You know the point of intersection of tangents at T1. So these coordinates are a T1 square comma 2a T1 and the coordinates are a T2 square comma 2a T2 and the coordinates are a T3 square comma 2a T3. Now the point of intersection of tangents at T1 and T2. So this is the point a T1 T2 comma a into T1 plus T2. Like the point of intersection of tangents. So at this point tangent and this is the tangent. The coordinates of B are B a T2 T3 comma a into T2 plus T3 and the coordinates of C. This is the point of intersection of tangents at T1 and T3. So this point is this is a T1 T3 comma a into T1 plus T3. Okay. Now suppose these points are called, this point is P, this point is Q, this point is R. Their point of intersection is what? A, B, C are the point of intersection of tangents at 3 points. 3 points. Now we have to show that the area of triangle formed by their tangents. So area of triangle ABC is equal, that means tangents, is equal to half determinant of same formula x1 y1 1. This is x1 y1. So this is a T1 T2 a into T1 plus T2 1. This is a T2 T3 a into T2 plus T3 1 a T1 T3 a into T1 plus T3, it is 1. Okay, up to this only. Now from the first column A is taking common, second column A is taking common. So half first column A, second column is also A is taking common. So this is T1 T2 T1 plus T2 1 T2 T3 T2 plus T3 1. So this is T3 T1. So this is T1 plus T3 1. Now here it is also R2 changes. You can change R2 changes. R2 changes same as R2 minus R1 and R3 changes R3 minus R1. R3 minus R1. So this is equal to, so this is 1 by, I can write here. So this is a square by 2, determinant of this is equal to just I remove this. So this is that is equal to 1 a square by 2 into this is determinant of R1 is as it is T1 T1 plus T2 1. R2 changes, R2 minus R1, so T2 is taken common. T2 is taken common, so T3 minus T1, and here it is T3 minus T2 gets cancelled, T3 minus T1, T3 minus T1, and it is 0. Next R3 changes, R3 minus R1, so here T1 is taken common, T3 minus T2, T3 minus T2, and it is T1 plus T2 minus T1 minus T2, T1 gets cancelled, T3 minus T1, T2, and it is 1 minus 1 is 0. So in the second row T3 minus T1 common, third row T3 minus T2 is taken common, so this is a square by 2 into T3 minus T1 into T3 minus T2 is taking common. So this is T1 plus T2 1, and it is T2 1 0. This is T1, this is 1, and it is 0. Now expanding along the first C3 third column, so 1 into the by deleting first row and third column. Okay na? By expanding this, a square by 2 into T3 minus T1, T3 minus T2 into 1 into by deleting this and this, so this minus this, that is T2 minus T1. So this is mod of, because of area, that is equal to a square by 2 into mod of, so T1 minus T2 into T2 minus T3, that doesn't matter, if you are taking minus is taking common, into T3 minus T1. Okay. Same as in the previous sum, that is equal to a square by 2 into, this is 2a into T1 minus T2, 2a into T2 minus T3 into 2a into T3 minus T1. So multiplying, this is 8a cube, so by 8a cube, that is equal to a square gets cancelled, 1 by 16a into, so this is 2a T1 minus 2a T2, 2a T2 minus 2a T3, 2a T3 minus 2a T1. So this is equal to 1 by 16a into, so this is y1 minus y2, and y2 minus y3, and y3 minus y1. What is y1? x1 y1 is a t1 square comma 2a t1. So this is y1 is 2a t1, 2a t2. This is the area of triangle formed by the tangents. The previous one is area of triangle inscribed in the parabola. So note, this we write 1 by 2 into 8a into determinant of y1 minus y2 into, so this is y2 minus y3 into y3 minus y1, that is equal to half of, this is area of triangle formed by the points. Area of triangle inscribed in the parabola. So 2 times of, this is 1 by 2 of 1 by 8a into, that is 1 by 2 of area of triangle inscribed in the parabola. That means, write one point, area of triangle that is area of triangle formed by the 3 points. On the parabola y square equal to 4x is twice the area of triangle formed by the tangents. Area of triangle formed by the tangents at these points. Area of triangle formed by 3 points. Points means y 3 points. On the parabola y square equal to 4x is twice the area of triangle formed by the tangents at these points. Next one, the equation of common tangent to the parabola y square is equal to 4x and the parabola x square equal to 4by is a power 1 by 3 into x plus b power 1 by 3 into y plus ab whole power 2 by 3 is equal to 0. Equation of common tangent to the two parabolas. See, first one is y square is equal to 4x is a parabola symmetric about x-axis. Second one is x square equal to, so we have to find the common tangent. This is the common tangent. So for y square equal to 4x, so the equation of tangent to the parabola x square equal to 4ay in slope form is y is equal to mx plus a by m. that is equation of tangent to the parabola y square equal to 4x in slope form is y is equal to mx plus a by m. So let it be, this is 1. Now 1 is also a tangent to the parabola x square equal to 4by. So here there are two methods. First one is you can write directly the condition for tangent. The condition that the line y equal to mx plus c is a tangent to the parabola x square equal to 4ay is c is equal to minus am square. This is the condition. First method. So this is y equal to mx plus c form. This is x square equal to 4ay form. Here a means what? Here b. So implies what is the condition? C equal to minus am square. This is the condition. That means that is nothing but a formula. So that is C means what here? What is C? A by m. Equal to A is what here? Y square equal to 4b. A is minus b. This is m is m square. So by cross multiplication, so this is m cube is equal to take this side minus a by b. Therefore m is equal to, so this is minus a by b whole power 1 by 3. So that is m. Okay. So in place of m you write this. So because this is a tangent to this parabola, this is also a tangent to this parabola. So from 1 you write y is, that is y is equal to, so this means what? Minus a power 1 by 3 by b power 1 by 3 into x plus a by m, where m is, so this is right, minus a power 1 by 3 by b power 1 by 3 y equal to mx plus a by m. So by simplification that implies, so just we get this one, that implies a power 1 by 3 into x plus b power 1 by 3 into y plus ab whole power 2 by 3 is equal to 0. So this is minus a whole power 1 by 3 means what? That is minus a power 1 by 3 into x by b power 1 by 3. Taking LCM and then cross multiplication, then you get this one. This is the common tangent for both parabolas. Next point, the locus of foot of perpendicular drawn from focus to any tangent to the parabola the locus of foot of perpendicular from focus to any tangent to the parabola is the tangent at vertex. Tangent at vertex. Tangent at vertex means is nothing but y-axis. See here, this is the parabola. So this vertex of parabola is 0, 0. Locus of foot of perpendicular from focus to any tangent. So this is the tangent. So what is the equation of tangent? Y is equal to mx plus a by m. Mx plus a by m. That is the tangent equation. So foot of perpendicular from S, a comma 0 to this tangent. This is the foot of perpendicular. So foot of perpendicular from focus to any tangent. This is the foot of perpendicular. So this locus is nothing but y-axis, means tangent at vertex means is nothing but y-axis. Slope of this line is tangent is m. What about slope of this line? Minus 1 by m. Slope is minus 1 by m. And what about the equation of this line? So slope and a point y minus y1 is equal to m into x minus x1. Now by eliminating m, that is the locus. So very simple. So equation of tangent y is equal to mx plus a by m. Equation of tangent to the parabola in slope form. Now the equation of line which passes through a comma 0 and perpendicular to this tangent. Slope is m, slope is minus 1 by m, point to slope equation. Now the equation of line perpendicular to 1 and passes through a comma 0 is y minus y1 is equal to m into x minus x1. Y minus y1 equal to m into x minus x1. So this is y is equal to minus x by m plus a by m. So this is second one. By eliminating m, that is the locus. How to eliminate? First one minus second one. And what is first one? Here y is equal to mx plus a by m. And the second one is y equal to minus x by m plus a by m. So this is second one. First one minus second one. So this is 0. Here x is taken common, m, this is plus 1 by m. And these two gets cancelled. That is 0. So since m is not equal to 0, implies x equal to 0. X equal to 0. X equal to 0 means what? It is nothing but y-axis. Y-axis means what? It is a tangent at vertex, which is the tangent at vertex. next one, the portion of the tangent intercepted between the point of contact and the directrix of the parabola of the parabola y square is equal to 4x subtends a right angle at its focus. The portion of the tangent intercepted between the point of contact and the directrix of the parabola y square equal to 4x. So this point is P, AT1 or AT square comma 2AT. Portion of the intercepted between the point of contact, this is the point, and the directrix. So this is directrix. So this subtends a right angle at the focus of parabola. That is the point. Intercepted between the point of contact, this one, and the directrix, this one. This, call it Q. This PQ subtends a right angle at its focus. Now you know the coordinates of P. Now we have to find the coordinates of Q. What is the equation of directrix? X plus A equal to 0. So that means what? X equal to minus A. Now equation of tangent at the point P. What is the equation of tangent? Equation of tangent at the point P, T is yt minus x minus at square equal to 0. Parabola is the continuous process, that is the concepts, this is linked concepts. If you are able to first understand first one, then only it is easy to second one. So these are completely based on concepts. If I neglect this one, so you feel little bit difficult. So thorough preparation, that is regular preparation, is very, very important. So equation of tangent at the point P, T is this equation. Yt minus x minus at square equal to 0. And what is equation of directrix? X plus A equal to x equal to minus A. By solving these two, you get the point, that is Q. So put x equal to minus A. So this is yt, so this is plus A plus A minus at square is equal to 0. Therefore yt is equal to a t square minus a into t square minus 1. Therefore y is equal to a into t square minus 1 by t. Therefore the coordinates of Q implies coordinates of Q are Q minus a comma a into t square minus 1 by t. Now you find the slope of SP and the slope of ESQ. You observe that their product is minus 1. Now slope of SP equal to slope of SP. So this is 2AT minus 0 by a into t square minus a. That is 2t by t square minus 1. So this is, let it be m1. like slope of SQ is equal to SQ. So this is A into, so this is x1 y1, x1 y1, x2 y2, y2 minus y1. So this is A into t square minus A by t minus 0 by A minus of minus, this is 2A. So this gets cancelled, t square minus 1 by 2t. So this is m2. This is m2. So this is minus A. So this is x1 y1, x2 y2, y2 minus y1 by x. This is minus. That is equal to minus of t2 t square minus 1 by. So this is m2. Just observing that m1 m2. So m1 m2 equal to minus 1. Therefore the this PQ makes an angle 90 degrees at its focus. Okay, thank you.